given that cos of alpha is -4/5, determine the other primary trig ratios of the angle alpha. So if we go back to our trig review, as far as types of questions, this is one where it says find the other trig ratios. So if you're finding trig ratios, all you're doing is using your definitions of sine, cos, and tan and writing opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. You're just using the definitions. But in order to use the definitions, you need a triangle, right? In order to write sine of theta, I need to see the triangle so I can write the opposite side over the hypotenuse. So that's what is missing in this question for us, is we're given that cos of alpha is -4/5, but we don't have the triangle. And what also is here that's different in grade 11 is that triangle could be in one of those four quadrants. We're told in this situation that cos is negative, so it can't be in 1 and 4, it has to be in 1 and 3. So I can take some time to draw an angle in quadrant 3, and I can draw an angle in quadrant 2. I can label the reference angle on both of those, and I can make a triangle. If I have that triangle, what do I know? I know that cos is adjacent over hypotenuse, adjacent over hypotenuse. And now that I have that triangle, if I had the other side, I could do sine theta. If I had the other side, I could do tan theta. So think back to your math. Could you figure out this other side? Is there a way to do that? Yes. A squared plus b squared equals c squared. So if you did a squared plus b squared, c squared is a hypotenuse, so that would be your 5. You would get, subtract 16 on both sides. Now when you square root, you should get plus or minus 3, but because we're talking about a length of the triangle, we're going to just label it as 3. So this question wants us to find sine of theta, and it wants us to find tan of theta. It says, determine the other primary trig ratios. So determining a trig ratio is just using the definition. Sine is opposite over hypotenuse. So we go to our reference angle, and if I look at opposite over hypotenuse, can you see for both of them, it would be 3 over 5. Should it be positive or should it be negative? That's our question. Because our angle, we don't know what alpha is. Oh, I did a tiny little notation error. Let me just take out eraser. If the angle is theta, your reference angle should be theta r. If the angle is x, your reference angle should be x with a little r. Since our angle was alpha, our reference angle should be alpha with a little r. And I also need to change these thetas to alphas. Sorry about that. Can you see yourself making that mistake? Writing the wrong variable? So again, sometimes what we do in a question is after we've done the question, we read it again, check for things like which variables were being used, and how's my notation looking. All of that clarity helps make our answer look better. And they have half-mark deductions in grade 11 and 12 as soon as you change variables, so it's good to check those things over. But the question was, should sine of alpha be positive 3/5 or negative 3/5? Well, here it's in quadrant 3. According to my cast rule, should sine be positive or negative? Negative. Good. But here it's in quadrant 2. Is sine positive or negative in quadrant 2? Positive. So sine, in this question, you would have to write that sine could be plus or minus negative 3/5. And you can see that from the pictures and your cast rule. And if you go to tan, tan is opposite over adjacent. Both of those ones with their reference angle, the opposite side is 3, the adjacent is 4. In quadrant 3 it would be positive, but in quadrant 2 it would be negative. So tan also would be plus or minus. And finally, for part B, it says find the angle alpha. So we would first use our triangles and find our reference angle. Reference angle always uses positive values. Cos inverse of 4/5. Get my calculator out. (36.86) it says to the nearest degree, so I'll round my reference angle to 37 degrees. What is my actual angle? Here's alpha, and here's alpha. In quadrant 2, it would make sense that you would go to 180 and minus your reference angle. So this one would be 143 degrees. And in quadrant 3, you would go to 180 and add your reference angle, which give you 217 degrees. And you can circle question 13. And I'm going to give you time to work on these.